Okay, so this next section is 3.2, and now we're going to get into solving inequalities. And this section is just solving with adding and subtracting. So it's important to remember that when you add the same number to each side of an inequality, the inequality remains true. So what does that mean? So it means, in an example, if I have an inequality like this, it says 1 is less than 6. If I add or subtract a number to both sides, look, I'm adding 2 and adding 2. So before it was 1 is less than 6, that's true. And now after I add 2 to both sides, I get 3 is less than 8. Well, guess what? It's still true. So that's just what this is meaning. The same thing happens with subtraction. So if I look at this example, 8 is greater than 2. Well, that's true. And if I subtract 2 on both sides, I still get a true statement. 6 is greater than 0, also true. These properties are true for whether it is less than, greater than, less than or equal to, greater than or equal to. And what we need to remember when we solve is we need to use inverse operations, okay? And we're going to see that come up a whole bunch. So let's get started. If we see this first example, we're going to solve them, and then also graph them is really important. Let's see here. It says b minus 2 is greater than negative 6. I want to get this b alone, so I'm going to move the 2 to the other side by adding 2. Remember, here's our inverse operations coming into play. If I'm subtracting, I need to do the inverse of subtraction. That's addition. That's why I'm adding. So then I'll be left with b is greater than negative 6 plus 2 is negative 4. And that's my answer. So then when I put that on the graph, just like the last video, I focus on this number. It's just greater than, so I put an open circle on negative 4, and then I'm shading all numbers greater than negative 4. That goes everything to the right. The next question, notice I want to get the m by itself, so I need to move the 3.8. So our inverse operations, if this is addition, I'm going to subtract 3.8 on both sides. So then I'm going to get 5 minus 3.8, that gives me 1.2. We bring down the inequality greater than or equal to m. Here's our answer. And now when I put it on the graph, remember it's helpful to always have the variable first. So if I just flip everything around, I'm going to have m, flip this around, less than or equal to 1.2. So I put my point on, closed dot on 1.2, and then I shade everything less than or equal to 1.2. Let's check out a couple word problems, guys. So this first word problem, it says on a train, carry-on bags can weigh no more than 50 pounds. As soon as I see no more, I'm thinking less than or equal to, right? If it's no more, if you're not sure, come up with some numbers to put in this example. Okay, 51, well that's more than, so it has to be less than or equal to. So right away I know I can write less than or equal to 50. Your bag weighs 24.8 pounds. Write and solve an inequality that represents the amount of weight you can add to your bag. So if I already have 24.8 pounds, how much more can I add to it? And so it's still less than or equal to 50. And so then I just solve that equation. I'm going to subtract 24.8 to both sides. Guys, this is important. I subtract because what's the sign right here in front of the 24.8? Isn't that a positive 24.8? So that's why I subtract it over it. So then I bring down what's left. I'm going to have x is less than or equal to 25.2 pounds. So I can add less than or exactly 25.2 more pounds to my bag. And then this next word problem here, the last one of this section, it says the perimeter. Remember, perimeter is the sum of the sides. The perimeter is less than 28. So right away, I'm going to go less than 28. Write and solve an inequality that represents the possible values of x. I'm going to add up the sides because that's a perimeter. 7 plus 7 plus x. I'm going to combine like terms. That gives me 14 plus x is less than 28. Then 14, I want to get this x by itself. This is a positive 14. So I subtract 14 over, and then I'll be left with x is less than 14. So this variable has to be less than 14 for my perimeter to still be less than 28. Okay? Good job, guys. This is the section 3.2.